Welcome back, students. So, sound is produced by the vibration of the object. So, sound travels in the form of wave. Sound travels in the form of wave. A wave is characterized by three basic quantities, that is amplitude, frequency and time period. Sound travels in the form of wave. A wave is characterized by three basic quantities, that is amplitude, frequency and time period. Okay. So, we will discuss about amplitude, time period and frequency. To and fro motion of an object is known as vibrations. To and fro motion of an object is known as vibrations. That small vibrations are known as oscillations. Small vibrations are known as oscillations. So, in class 7, we studied about the oscillation of a simple pendulum. The simple pendulum consists of a small metal ball called bob suspended by a long thread from a rigid support in such a way that the bob is free to swing back and fro. So, in class 7 you studied about simple pendulum. A simple pendulum consists of a metal ball, that is known as the bob of the pendulum, and is suspended by a long thread from a rigid support in such a way that the bob is free to swing back and fro. So, the motion of the bob of the pendulum from one extreme position to the other extreme position and back is called one oscillation of the pendulum. One oscillation of the pendulum. So, here I will draw it. This one is a rigid support. Rigid support. With the help of a long thread, I am hanging this bob. So, this one is a bob. So, it will move. This one is the extreme end, one extreme end. This one is the other extreme end. Name it as A, B. Okay. So, when this bob starts from A to B, then back to A. Suppose the bob starts from A to B, then back to A. That is one complete oscillation. That is one complete oscillation. It's one complete oscillation. So, this distance is represented by the amplitude. Amplitude. This distance. This is the mean position. From the mean position towards the extreme position. That is represented by the amplitude. So, here I will draw two diagrams. One, this is the mean position. This one is the extreme position. This one is also the extreme position. This distance is represented by the amplitude. This distance is represented by the amplitude. Here it's small amplitude. Small amplitude. Small amplitude. Small amplitude. Next I will draw another one. It's a rigid support. This one is a mean position. This one is the extreme position. This one is the extreme position. So, this one, that is the amplitude. Here it is having large amplitude. Large amplitude. Now we will draw this one in the form of a wave. In the form of a wave, we will represent it. So, if you want to represent it in the form of a wave, we need two axes. This one is the time, this one is the amplitude. So, from this origin, I will draw it. So, that is a small amplitude. This one is the mean position. This one is the mean position. This one is the extreme position. This one is the extreme position on the other side. So, maximum displacement from the mean position, that is represented by the amplitude A. Maximum displacement from the mean position, that is represented by the amplitude. Okay, maximum displacement from the mean position, that is represented by amplitude. Here it is small amplitude, here it is large amplitude. Time, amplitude, here it is large amplitude. Large amplitude. Maximum displacement from the mean position, that is known as amplitude. Okay. Now, the loudness of sound is proportional to the square of the amplitude of the vibration. If the loudness is twice, if the amplitude is twice, the loudness is increased by a factor 4. Means loudness is proportional to amplitude square. If the amplitude is 2 square, the loudness will be increased by a factor 4. If the loudness is 3 square, the loudness is increased by a factor 9. Now, the SI unit of loudness is decibel. SI unit of loudness is represented by the unit decibel. Decibel, it is represented by the symbol dB. It is represented by the symbol dB. So, maximum displacement from the mean position, that is represented by the amplitude. This one, here it's soft sound. This one is soft sound because the amplitude is less. Amplitude is less, it is known as soft sound. This one is loud sound because the amplitude is more. The amplitude is more, so it is known as loud sound. Next important term is frequency. Frequency means the number of complete oscillations in 1 second. Number of oscillations in 1 second. How many oscillations are completed in 1 second? That is known as a frequency. One oscillation means one upper portion and one lower portion. One upper portion and one lower portion. That is one cycle. This one, I will draw it here. Number of cycles or number of waves or number of oscillations in 1 second. So, when you draw a wave like this one is upper portion, this one is a lower portion. So, this represents one oscillations or one wave. So, you will count how many waves are there in 1 second. That represents a frequency. That represents the frequency. Here one wave, one upper portion and one lower portion consists of one wave. So, how many waves are there in 1 second? That represents the frequency. Here I will draw 2 wave, 3 wave. If 3 waves are produced in 1 second, then the frequency is 3 hertz. 3 hertz. This one is low pitch. Low pitch means number of waves less. Number of waves less, or frequency less. Number of waves less or frequency less. That is about pitch. Okay, that is about pitch. Now I will draw it another wave. Now, when you compare this diagram and this diagram, in the second diagram, that is this one, name it as A, this one is B. In the second diagram, you know this, the frequency of the wave is more, means number of waves are more. So, it is having high frequency or high pitch. High frequency or high pitch. High pitch, high frequency, high pitch, high frequency, or number of waves number of waves more. Number of waves more. So, here you can count one positive half and one negative, or one upper portion and one lower portion consists of one wave. So, here in the second diagram, the number of waves are more. In the second diagram, the number of waves are more. So, it is having high frequency, high pitch, or number of waves are more. That is about frequency. Now, the SI unit of frequency is hertz. SI unit of frequency is hertz or Hz. SI unit of frequency is hertz or Hz. The voice of children and ladies is shrill or high pitch as compared to the voice of men. This is because the children and women have shorter vocal cords which therefore vibrate with a high frequency to produce a high pitch sound. The wings of the bee and mosquito vibrate with high frequency, hence the sound produced by them is shrill and high frequency or high pitched. The skin of a tabla or the string of a guitar are tightened. They give out a sound of high pitch than when they are loose. When the skin of this tabla, the stretched skin is there in tabla. So, when you tighten that stretched skin, or when you tighten the stretched string of a sitar, then it will give high frequency sound compared to when they are loose. When their skin or when their stretched string is loose. In the flute, the sound is produced by the vibrating a column of air. The frequency of vibration is altered by closing the holes of a flute, which changes the length of the column of the vibrating air. When more holes of the flute are closed, a note of low pitch is produced. When less holes of flute are closed, a note of high pitch is produced. So, the frequency of the vibration in a flute can be changed by closing the holes of the flute, which changes the length of the air column, which changes the vibrating length of the air column. So, when more holes of the flute are closed, it produces low pitch sound. When less holes of the flute are closed, it produces high pitch sound. Then suppose if an object oscillates 20 times in 1 second, what is the frequency? 20 times in 1 second means 20 waves will be produced in 1 second. So, its frequency is 20 hertz. Its frequency is 20 hertz. If an object vibrates 256 times in 1 second, 256 times it vibrates in 1 second, then its frequency is 256 hertz. 256 hertz. Now, one more equation is there to find time period and frequency. One more equation is there to find time period and frequency, that is time period equal to time period means the time taken by an oscillation. Time period is the time taken by the pendulum to complete one oscillation. That is known as time period. That is the time taken by an object or the time taken by the pendulum to complete one oscillation. Now, one more equation is there to find time period, that is time period equal to time taken divided by number of oscillations. Time taken divided by number of oscillations. Now, there is a relation between time period and frequency. There is a relation between time period and frequency. Time period equal to 1 by frequency. Time period equal to 1 by frequency. Time period equal to 1 by frequency means or frequency equal to 1 by time period. Okay, frequency equal to 1 by time period. That is, or we will write in another way, frequency equal to 1 by time period. Now, what is a unit of time period? The unit of time period is seconds. So, the frequency, the SI unit of frequency is 1 by second. 1 by second, that is equal to hertz. 1 by second, that is equal to hertz. So, that is the unit of frequency. Frequency equal to 1 by second, that is equal to hertz. Now, we can write one more equation for frequency, that is frequency equal to number of oscillations divided by time taken. Frequency equal to number of oscillations divided by time taken. So, with this equation and with this equation, problems are there to do. Okay, problems are there to do with this equation and with the equation to find frequency. Okay, that's given in your text back page number 5 and 6. That is, a simple pendulum oscillates 40 times in 4 seconds. 40 times in 4 seconds. Find the time period and frequency. Find the time period and frequency. An object oscillates 40 times in 4 seconds. So, You have to find the frequency and the time period. So, page number, text back exercise, question number 5. Text back exercise, question number 5. So, number of oscillations that is equal to 40. How many times it will vibrate? That is equal to 40. Now, time taken to complete that oscillation. Time taken to complete that oscillation, that is 4 seconds. So, the question is, a pendulum oscillates 40 times in 4 seconds. Find its time period and frequency. So, now we will write the equation to find time period. Time period equal to time taken divided by number of oscillations. Time taken divided by number of oscillations. That is, what's the time taken? 4 seconds divided by 40. 4 seconds divided by 40. So, the answer is 0.1 second. Thus, you will get 1 by 10, that is 0.1 seconds. That is the answer when you calculate the time period. Now, we need to calculate the frequency. So, we will write the equation. Frequency equal to number of oscillations divided by time taken. Number of oscillations divided by time taken. So how many oscillations? 40 oscillations in 4 seconds. 40 oscillations in 4 seconds. So, the answer is 10 Hertz. 10 Hertz. In the same way, you can do the question number 6 also. Question number 6 also you can do in the same way. Thank you.